Hello everybody. We're going to talk about several different types of numbers. The number types we're going to discuss are counting numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. My goal is to just introduce these number types to you right now. In other lessons, we'll be looking into these numbers in much more detail. So if you don't understand everything right now, don't worry about it too much. These different number types came about as arithmetic evolved through history. Remember that the central purpose of mathematics is to be a tool for solving problems. As civilization progressed, the need to solve increasingly difficult problems became necessary. So mathematical tools were refined and new ones were developed. If you look at the different number types as the creation of new tools to solve new problems, then I think it makes things easier to understand and remember. The first type of numbers are counting numbers. If I ask you to start counting, you are likely going to present me with this group of numbers. This is the first and most simple application of arithmetic. Parents teach infants to count at age 2 or 3, and we know from archaeological evidence that the concept of counting numbers has existed for at least 50,000 years. Counting numbers are used to provide us with very simple but important information about objects in our world, namely how many of them there are. We can count trees in a forest, or deer in a field, or as the ancient Greek philosopher Archimedes famously attempted, the number of grains of sand needed to fill the universe. Whole numbers are simply counting numbers with one added number, 0. 0 as a number was first conceived about 2,000 years ago in both Mesopotamia and the Mayan culture. The concept reached India, then Arabia about 1,200 years ago, but didn't reach Europe until about 1,000 years ago. This is the time that Europe began to use the symbols for numbers similar to what we use today. In this system of counting, 0 was crucial in order to be able to distinguish between 12 and 102, for example. Integers are the whole numbers with the addition of what one of my students once cleverly described as negative counting numbers. Historically, the concept of negative numbers predated 0, but it took a long time for them to gain acceptance in Europe, since the ancient Greeks, who deeply influenced scientific and philosophical thought in medieval Europe, were largely uninterested in any mathematics that did not help to explain or describe the physical world. Negative numbers are useful, though, for the financial counting of merchants and bankers, who were both borrowing and lending money and goods. And so the integers finally came into widespread use about 600 years ago. You'll notice that I represent both the positive and negative integers using 3 dots at the end of each sequence of numbers. Those 3 dots mean that the sequence keeps going beyond what I have represented. That is, the positive integers go beyond 5 in the positive direction, and the negative integers go beyond -5 in the negative direction. How far do they go? As Renaissance astronomers began to get glimpses of how large the universe was, they started to discuss large positive numbers. It was pretty clear that no matter how large a number I can think of, you can think of one that is larger. So in 1657, the symbol for infinity was introduced for both positive and negative integers. We're going to deviate from a purely historical presentation of numbers when we talk about rational and irrational numbers. The dictionary definition of rational means to be based on or in accordance with reason or logic. But in mathematics, rational is derived from the term ratio, something that we usually call a fraction nowadays. A rational number is simply one that can be expressed as the ratio or fraction of 2 integers. For instance, 2 over 3 or -4/7. Rational numbers were created by the ancient Greeks as a tool for expressing the division of one object into smaller parts. I need to clear up a common misunderstanding about rational numbers from the beginning. Recall that I said that rational numbers are numbers which can be written as the ratio or fraction of 2 integers. That doesn't mean that they have to be written as the ratio of 2 integers. For instance, the number 2 is not written as the ratio of two integers, but we can write it in an equivalent form such as 2 over 1, 4 over 2, or quite a number of other equivalent expressions. So the number 2 is a rational number, as well as all of the other numbers that we have discussed so far. Irrational numbers were one of the few areas of mathematics that weren't created. Instead, they were discovered by the ancient Greeks. The dictionary definition of irrational is something which is not logical or reasonable. The mathematical definition of an irrational number is a number which cannot be expressed as the ratio of two integers. It turns out that there are many irrational numbers which we encounter in mathematics. Two good examples for right now are pi and the square root of 2. The ancient Greeks valued orderliness in the physical world, and they were not very happy with the discovery of irrational numbers. Irrational numbers aren't orderly, and they aren't tidy. Most math students for the intervening 2,500 years have been similarly unhappy with studying irrational numbers. For those of you who have experience with irrational numbers, take a minute to give me your thoughts. Did you enjoy working with irrational numbers? Okay, that's enough. Popular or not, we will learn in future lessons how to successfully deal with irrational numbers, and eventually you will become comfortable with them. Well, at least more comfortable than you're probably right now. Let me take a moment to talk about sets before we go any further. We can call any group of numbers or objects related to each other a set. We can talk about a set of dishes or a set of socket wrenches, and in mathematics the use is similar. A portion of a set is a subset. So, using our analogy of dishes, we can say that all our cups are both a set by themselves and a subset of all of our dishes. All of our dishes are, in turn, a subset of all of our possessions. In a similar manner, we can consider the counting numbers as a set by themselves. But they are also a subset of the whole numbers, which are in turn a subset of the integers, which are a subset of the rational numbers. The irrational numbers are a set as well, but the counting numbers, whole numbers, and integers are not subsets of the irrational numbers. Any number we choose has to be either a rational or irrational number, but it cannot be both. I'm going to introduce one more type of number, the real numbers. This set of numbers will include both rational and irrational numbers. In fact, every number that you are likely to encounter will be a real number. The latest trend in mathematics is to move away from its application as a tool and into more of a theoretical realm. Along these lines, we talk about real numbers because we have two more sets of numbers called complex and imaginary numbers. Neither complex nor imaginary numbers exist in the real world, so they are principally studied in the field of theoretical mathematics. You know, as I think of it, let me tell you a little bit about complex and imaginary numbers. Okay, I guess we'll stick with real numbers, and so we are done. Thank you, and have a good day.
We hope to see you at Veterans Upward Bound very soon, and recommend a friend.